Harald Kloft is a structural designer and a professor for structural design at the Technical University in Braunschweig, where he's also heading the Digital Building Fabrication Laboratory, a large-scale roboter-aided fabrication facility that you will, I guess, see in a minute here. He studied civil engineering, started to do that in 1990 at the Technical University in Darmstadt. He was then working for Strabag Bau AG, came back to the university to do a PhD that he defended in 1998. And from 1998 to 2001, Harald was working at Bollinger Grohmann Ingenieure, a large engineering company in Frankfurt, and there he was working in the early days of digital fabrication, exploring completely new ways to build things. In the late 90s, he became a visiting professor for structural design at Städelschule, and in 2002 he established his own office, OSD, Office for Structural Design. In 2002 he also became a professor at TU Kaiserslautern. He was a professor from 2007 to 2009 at the Technical University in Graz, and since 2011 he is in Braunschweig. And since very recently, he's not only the founder of OSD, but he kind of changed his role a little bit and also became a consultant. Harald is what he says, printing with pressure, which works even better in German, drucken mit Druck. And I guess you will now show what that means. Thank you very much for being here today.
Yeah, thank you very much, Oliver, for your introduction, and Ulrich also for inviting me. And it's nice to see some of the protagonists, Matthias Michel and Arno Walz, from the early days of digital fabrication. Yeah. Maybe it's really loud. It's okay with the sound? Okay. Yes, I'm for a few years we're now doing research in 3D printing, additive manufacturing, and we developed a method at TU Braunschweig called shotcrete 3D printing, which I want to show you today, and also to give a little bit feedback around why we did this and how is the future in our opinion. It's always a teamwork, so it's important that it's not something, okay, I'm presenting this today, but I'm really proud to have a really strong team of architects and engineers, and as well in Braunschweig we are one faculty with architects and engineers, and I'm a structural engineer, and working on the interface between both departments, and this is really fruitful, especially for such interdisciplinary work. For me, it's always important, Oliver mentioned this, I'm now for a long time in structural engineering, and you have your own experience, and so it's always important to not to step back, but to look back. So if you are going forward in research, it's always important to know the environment, especially how the building industry is organized and how this the daily work is running. And if you compare those two images, left is the Berliner Bauakademie from 1836 by Carl Friedrich Schinkel. So there are close to 200 years between both images, but you don't see really the progress. So of course we have a lot of new regulations in building physics, and we use concrete, and we have a lot of technical equipment inside, but if you look to the articulation on the facade design and also the structural design inside was in that time really revolutionary. And so if you look to other industry areas, for example in car industry, then there is really obvious and significant visible the progress. For example, in car industry, so the first car, the first Mercedes-Benz is more or less a horse carriage, And today, nobody could imagine in that time to drive by himself. And today we have the newest model, so in the future we will get driven. But you see the development is totally different. And if you look back for the reason, then of course is a strong connection to the technological evolution. So a major step was the series production, the introduction by Ford in 1924. And today this is the basis that every series production is done by robots. And on the other side, if we look to our technical evolution in building, for example, in concrete construction, then we still use the technique which was developed 100 years ago. So we still, you see here we have, I don't know, 8 people, and still we need 8 people to pour the concrete in the formwork. And this is, on one side, is an old technique, on the other side is the reason for all the cost development or the end of the cost reduction in construction. And this is significant also in the productivity of our industry. So you see that the building sector has no development in the last 40 years, whereas other areas, they have a strong development. So that means if you sell a car, so they earn much more money than we do if we build a house. So everybody has a lot of work today, but is not really productive in terms of economy. The other thing is that we really are one of the major sectors for the material use. So this is one of the reasons that we have to take care really on the CO2 emissions also in our area. And we need too much material because of this old technique. What is the benefit of additive manufacturing? And we discussed before that we did 20 years ago still the first project with digital fabrication technologies. But the difference is that we had to use techniques from other areas, from other industrial areas, and had to apply them to our needs for a building. And the main difference is that each building is unique. So we have really the requirement on individualized production. And this is the difference to all the other areas. They mostly go in a series and still in additive manufacturing. So a serial production in the future means that you have a lot of printers doing the same thing. And the main difference in construction is, at first, is the scale. So we don't have this kind of printers for the large pieces we have to print. And the second thing is that the precision other industries need is not that maybe what we need. Because a wall is a wall, and it doesn't matter if the surface is really precise or not. So the structural working is not a question on the surface. This is more aesthetics. And we are used to put another layer on the surface. And so this is a big advantage to all the other functional 3D printed pieces. In construction, we can classify more or less 2 main areas. This one is the particle bed printing technologies. That means that layer by layer the material is applied by selective paste intrusion or by selective cement activation. And on the other side we have this deposition, that the material completely is mixed before and then applied layer by layer. This is the more or less the most common technology in construction, the extrusion of ready mixed material. Oliver mentioned this before. The chance and the challenge of 3D printing in construction is really that we start to new think. So if we have just formwork and we pour in concrete, then there is less chance for the articulation of the composite material inside. But if we now start with build up layer by layer, so we have the chance to do new design. So the question is about the logic of form, and we still are at the beginning. So there are a lot of ideas coming up now, and from different ideas you see here, this is particle bed 3D printing. So what kind of limitation we have for the shape of a printed piece, but still you see that we have also to address the question of reinforcement. So how we get the printed pieces really in a usable form for construction. And this is what we are doing in Braunschweig, so with our team at the Institute of Structural Design, but also with my colleague Jack Loke, Norman Huck, and other institutes from mechanical engineering. So we step forward now, and we are looking for resource-efficient structures with a new logic of form. The question how to integrate reinforcement, the question about how to guide materiality, how we can print with different materials in one construction, in one element. These are the main questions for us in the future research. But now the focus is on shotcrete 3D printing. I now like to show you some of our latest works. And the first question is why shotcrete 3D printing? You see that this is an old established technology, so to shotcrete or to shot the concrete, and all the questions we have, they are still in this technology and developed. So you see the reinforcement is integrated, so there is really experience how to embed and how to integrate reinforcement in the shotcrete constructions. Also the surface finishing, the smoothing of the surface, but everything is done manual by hand. And this was the reason for us to say why we could not do this in a robotical and controlled automated process. And 3 years ago, we opened the Digital Building Fabrication Laboratory at our university. And the first idea was, I step a little bit forward. The first idea was, and this is also very interesting for us, so that at the beginning we are so, how do you say, so informed by the contemporary technologies that it always needs some time to develop the new technologies. So the first idea was, okay, shotcrete, you shot against something. And so we were thinking we need this robot who is spraying the concrete, and on the other side we need a formwork. But the formwork should be active, and this should be developed in a collaborative process. So the first tests we did were done in this collaborative process, and you see we had really one nice side, and the other side we could not control to build up an element. And also you see that then we thought months how to get the problem solved that the material will not break when the formwork is moving forward. But then, I don't know, it's like a mind gap. So it's from 1 second to the other, you say, okay, why not the floor is our formwork. Why we cannot spray just to the floor? And then the development was incredible fast, and the same robot did the same thing, but he didn't spray against an active formwork, he just sprayed to the floor. And then we took some test specimen out, and we checked all this, and was really impressive that the materiality inside, from outside it looks ugly, but from inside was really homogeneous, the material over the layers and over the over the layers. And then we compared to poured concrete, and we saw that it's just better. So the compressive strength of the shotcrete material is just better than the poured concrete construction. And then we started to do this really in a kind of research program. So we had a lot of parameters to guide the printing rate, the conveying speed, the nozzle distance, the spraying angle. Then the major thing was what we developed then is the addition of accelerator, because after 15 to 18 centimeters, all the pieces we printed at the beginning, they collapsed. And so this was one of our major gaps, how we could control, because we are really fast in printing, how we could control that the material get hard enough to carry the lower layers. And of course the addition of air pressure, this is really important, not too much and not too less. So, and we did a research program to calibrate all these different parameters. The first test we did, the column is in the exhibition downstairs. This is also a mind gap. So if you, just a column, if you pour a column, then you have a formwork and you put the concrete inside. So there is no, if you really want to make a hollow space inside, this is a difficult thing. But if you print, you don't print the full volume, you just print the ring. And so first things first, okay, how we get fill the inner, the middle? And we said, no, we don't need to fill. Why? It's like in steel, you know, it's just it's a hollow profile. And we can use it and can post-tension the pieces, and then we have a reinforced column. So, but this was not the idea at the beginning when we started, but this was during the process we got all these ideas. And the next step is here, if you go back, this is all the 3D printers they have normally, so that if you want to make this overhang, you cantilever piece by piece, layer by layer, and you lose from your section. And we have a robot with our 6 axis, and we said, okay, why we could not vary the angle, and then we have the full section for carrying the load. And this is also a new idea, which is by itself integrated in this process. In summer, now we working on reinforcement. This is the main topic now. Of course, you can post-tension the columns, but we now really take normal reinforcement and integrate this in our printed pieces. And it's difficult for the robot to print around the prefabricated reinforcement. So we designed a rotating table. This is 1-to-1 speed in real time. Of course, the column looks ugly, and we're now working on a integrated smoothing process. But for us it's more important to really do research on the integration of the reinforcement, and we compare it to the normal poured concrete columns, and they are comparable. And they look ugly, but structurally they are comparable absolutely to a normal reinforced column. This is a question for an engineer, is not that important about the surface, but for architects it's always very important. So we say, okay, in the future we could imagine you can have this wall with just 3D printed, and you could say, okay, this is aesthetic, this is nice design. If you remember 100 years ago, the first formwork was wood, so when we got this system formwork, nobody could imagine that concrete should not look like wood. And today nobody could imagine that concrete has to be very precise and smooth on the surface. And but we developed technologies that we said this is a second layer. So it's not like I showed before that this should be done in one process. If you put on mortar later or something like this, you could do it with different material, or we print on a second layer on top. And then we have developed a rotating tool, which is taking when the concrete is just fresh enough with less energy, makes the surface really smooth. Another advantage for the second layer printing is the integration of fabric reinforcement. So it's easy to print a second layer and just to do it manually, to put in the reinforcement and then to print on top again. And then we could have a wall with textile reinforcement on both sides. Another case study we did this year about reinforcement was that we wanted to print a shape with a kind of wellies, and then we did prefabricated reinforcement in the horizontal layers and were able to integrate vertical reinforcement in these hollow spaces. You see it here. And this is also the difference. So shotcrete is not really a precise technology. So we are really fast, and we can build up strong elements. But if you want to really have precise, geometrical, complex elements, then a particle bed technology is much better. This could be done then manually, so to integrate the reinforcement. We are working now on augmented reality, so that you exactly get the position where to lay down this reinforcement. And then we print a second layer on top again, so that the reinforcement is completely embedded. And then start to smooth the surface. Okay, I can make it now shorter. Another advantage is that we are able to print free in the space. So one thing is, of course, to build up vertical by vertical layering, but we also are able to print horizontal layers on the elements. And so with no formwork, you are able to do consoles or ribs on a structure. And this is something we developed last year, that nobody actually has some idea how to print slabs and ceilings. And it, of course, makes no sense to print layer by layer for filling a plate. But what is interesting is that today we are used to to do 30 centimeters in thick slabs because we avoid to build ribs because of the cost for the formwork. And with this hybrid technology to make a really thin blade and to print on in the fresh concrete, in the fresh poured concrete, the ribs by shotcrete 3D printing, you get really a new technology for really efficient production of slabs with ribs. So this is a test for just a normal uniaxial blade. This is 6 centimeters with ribs. And what is also nice that you are now able to do the ribs in the shape of the bending line. So it's not necessary to do it 30 centimeters over the whole length. So in the middle, you need much more. And to the end, you could print less material, and we do it by the speed, so we control the speed of the robot, and so there we can vary the thickness. And the reinforcement, this is another advantage. We stop the robot, and this could be done manually, so it's really easy. You don't need additional reinforcement just for positioning the reinforcement you use in the tension areas. And then again, the robot prints on another 2 layers so that the reinforcement is integrated and embedded in the concrete. And here you see the final product and the digital model. So it's always, you have to plan this before, and then you see here, this is the poured concrete and the printed concrete. And this gives us the chance now also to be free in the design. So you all know this nice works from Pierluigi Nervi, for example, this Getty Wool factory. And this is also what you could do. So this is a blade for a point bearing blade for 2 axial load bearing. And this is 4 by 4 meter, really efficient. And it's just printed on top of the slab. Yeah, the future vision, I just had a short discussion with Arnold Walz before, so the question of BIM. I also avoid a little bit to pray that BIM is the future in construction, because BIM is just a planning tool, and our processes are much more complex. And our vision is that we start from the beginning. We have to develop now new digital fabrication methods, and additive manufacturing is, in my opinion, a key technology for digitizing the building industry. But this is not a sequential process. So it's not that we start with architectural design, then we plan, and then we manufacture, like we are used to do it now. The future is much more interactive. You can name this digital twin, like everybody is doing. You can name it in other words, I don't know. But important is that in each phase from design to manufacturing, we have to get digitally connected. And this is the advantage, that still at the end, you could maybe change things in the design for the next pieces, and this will make it much more efficient, and hopefully we have altogether more fun in working in construction than today with our old techniques. Thank you very much.
Thank you very much, Harald Kloft, for this amazing lecture and amazing research.
My English is always, I'm a little bit slow in this language, but it's okay.
Are there any questions? We will.
Talk about the speed. What kind of volume are you extruding or pressure and out per hour in terms of volume of concrete or in terms of tonnage?
close to 1 cubic meter per hour.
Can you give us an impression of the strength of the material? Many 3D printing approaches with concrete have the problem that the strength of the printed material is much lower than the original material if you use it in conventional ways.
Sorry, do you mean the compression strength?
Yeah.
If this is lower,
Yeah.
this tends to be higher. So we use here ultra high performance concrete, which has 60 to 70 megapascal, and we get, if you pour this, I would say 10% higher compressive strength with shotcrete technology. Ja, Arnold.
Das Problem, wenn wir diese digitalen Tools einsetzen wollen, sind natürlich Daten. Und im Moment muss man einfach feststellen, dass die Planungstools, die üblicherweise in der Architektur verwendet werden, diese Daten nicht liefern können. Weder von der Konsistenz noch von der Qualität und so weiter. Und deshalb, wir brauchen eben, um letztendlich diese Technologien in unsere Arbeit zu integrieren, bessere Planungstools. Ja. Also darauf müssen wir auch achten, sonst bringt das nicht viel.
So everybody speaking German here, or no? The question is about the tools, and this is important. So I didn't bring this one graphic, but we now focus on the digital fabrication technologies in research, but also we are strongly working on digital design, so on this integration. And like Arnold said, if you start here with new ideas, you really, or if you start here with new technologies, you get new ideas about the design. For example, this slab is something which was not planned. You get this idea why we could not do this in this way, and then this will change also the design and the tools. Yeah. Okay.
There's one more question, please.
Regarding reinforcement, what kind of materials do we use besides steel? Can you use fiber for 3D printing?
Yeah, we have a research project running where we look on different materials, carbon fibers, and steel, of course, and also micro steel fibers. So, and I think this is just the interesting thing on the shotcrete technology is that like I showed before, that this is established and also is integrated in our regulations. So shotcrete, we are used to have the regulations how we do with this, and this is why we try to first work with steel reinforcement. But in the future we will have a mix of reinforcement. So it's easy to lay down something horizontal in the layer, but if you really have to have vertical or under an angle the reinforcement, then the question is how do you do this? So how you integrate steel, and so we have different ideas on this. Yeah. You had a question?
I have a question regarding concrete. Do you have now activities regarding new concrete, which is more sustainability and sustainable as the current one in this direction?
Yeah. The question is about the concrete itself, and I mean this is high-tech material, and actually I always say we combine high-tech material with high-tech technology, and this of course is in some way really efficient, but this needs new design. So it makes no sense really to build up just a normal wall with this high-tech material, but maybe you have just the structure of a wall, and then the question is how you fill the rest to get a wall as a closed, geometrical closed element. And there we have different ideas, also with recycling material, so and also with rammed earth. So the combination of hybrid material and also hybrid technologies. Yeah.
Okay. Thank you again.
Yeah,
for
thank you.
this great lecture.
Thank you.
And we will now move on, and we are happy to welcome our next speaker, which is Theo Salé.